Here in this video, we are solving a NEET 2025 question from logic gates, which is a part of semiconductor devices. A circuit is given for you and you are asked to find out what is the output is, right? So we can do it in a kind of a logical way with a simple numbers rather than going for a Boolean algebra. I don't want to go like that way. I want to do it in a simple way. So let me say what is the inputs given for you? A, B, and we will see what is the output at each these levels, which are the inputs at these levels, and what is the output at this level, right? So A, B, I will write a final output. I will write only final output, but we'll analyze in between, right? Yeah, assume like A is 0 and B is 0. So here we are starting with A 0, B 0. This is also A, so this is also 0. Look at this gate. This is an OR gate. But if you see a circle around, this is a NOR gate. So what happens? What is the output of the OR gate is A plus B. It's like a union function. If any one is true, other one is also true. Output of this one is A plus B bar. That means negate of that. Similarly, if you look at this is an AND gate, intersection function, A and B. And this is again a NOT gate. That means this is also going to be negation of that. Let me come up to that. Again, if you look at this, this is an AND gate. This is A and B. Okay, intersection function. Any one is true, the output is true. I'm not going into very detailed approach of that, what is an AND gate and so. If you want it, please look into the list that we have made for the semiconductor devices. We have a playlist there. Yeah. Now A is 0, B is 0. So here we get 0 input. Here also will get a 0 input. Being an OR gate, I will get 0 because any one is not true. But it's a NOR gate, so I will get here an output of 1. Similarly, B is 0, A is 0. And this AND gate gives 0, but because of this NOT gate functionality, I will get 1. Right? Now here the inputs are 1 and 1. AND gate, so gives output of 1. So the final answer here is 1. Right? We have done that part. Now let's go for the second step. Like you give A equal to 1, B equal to 0. This is A, so it is equal to 1. I'll take a different color so that it becomes easy for you to identify. Yeah. A is 1 and B is 0. R will give you output of 1 because R means union function. But this NOR will give you output of 0 for that because it's a negation. Again, B0 and A is, so what's the second option I'm taking? A1, B0. So A is 1, B is 0. 0 and 1 AND gate gives an output of 0. But because it's an AND gate, it gives output of 1. So here I will get a 1. Right? So I got 1, 0 here, I got 1 here. 0 and 1 for AND gate gives an output of 0. Right? So too many numbers on the screen might confuse you. That's why I'm just deleting all the numbers I have written so we can have a fresh look with the numbers again. Yeah. Yes. Let me take a different color now. Yes. Yeah. Now I will take an options like A equal to 0, B equal to 1. A is 0, B equal to 1. This is again A 0. For this OR gate, 0 and 1 are the inputs. So OR will give you 1, but this is a NOR gate. So it will give an output of 0. Now for this second part, 1 and 0 are the inputs. AND gate gives you 0, but NAND gate gives you 1. So here the inputs are 0 and 1, which is an AND gate. So the output is going to be 0. So here also 0. Now you give inputs. I'll take a different color again. 1 and 1. A is 1, B is 1. What happens? Now A and B is 1. OR gate gives you 1, but it's a NOR gate, so it will gives you 0. Again, B and A are 1. AND gate gives you 1, but NAND gate gives you 0. For a AND gate, 0 and 0 output is also 0. So the entire output of the screen is this 0, 0, 0, 0. 1, 0, 0. This is the output. So what is this gate is actually? What is this output is? This we can very easily identify, right? How can we identify? OR gate means output is, I'll write an output here. For OR gate, only when both options are zeros, everything is 0. Otherwise, it is 1 and 1. Yeah, this one, right? And if you write for AND gate, that is, so this option is not the case. This is definitely ruled out. Look at the AND gate. AND gate means only for 1 and 1 output is 1 intersection function. Everything else is 0. So this is also not the answer that we have got. This is what our answer we have got. NOR gate means reverse of OR gate. OR gate 0 means NOR gate is 1. Like this. NAND gate means reverse of AND gate. Wherever zeros, there is 1. There is 0, 0, 0, 1. 1 has to become 0. See, if you see your output carefully, this is similar to NOR gate. So our answer is NOR gate. That's how you have to solve the problem. It's a very easy way to solve the problems by taking 0 and 1. Otherwise, you have to learn a lot of Boolean algebra. That's your choice. It can be solved based on Boolean algebra also. Thank you for watching.